Hello, today we're doing 5.4 day 1 or factoring polynomials. Now I'm going to do the factoring quite quickly because we've been factoring this entire year. The difference with this and this section is there's a lot of double factoring, and there's a new type of factoring when we're factoring perfect cubes. Alright, so let's go ahead and get started. A factorable polynomial with integer coefficients is factored completely if it is written as a product of an unfactorable polynomials with integer coefficients. So if I look here, this is factored completely. There's nothing more I can do with 2, with x plus 1, or x minus 4. This one is not factored completely because this can go further. This is difference of squares. I can factor x squared minus 4 to be x minus 2 and x plus 2. So that's why we said that what I originally had was not factored completely. Okay, let's just go ahead and get started practicing. The first thing you definitely want to make sure you do on all these problems is see if there's a greatest common factor. In this one, I can divide out a 2y cubed. When I do that, I'm left with y squared minus 9. Now look, I'm not done. This is difference of squares. So I'm going to write my 2y cubed, but I'm going to continue on. Y squared minus 9 would be y minus 3 and y plus 3. Okay, this one, we're going to go ahead and take a 4 and a z squared out. When I do that, I'm left with z squared minus 4z plus 4. Now, this is actually simple AC factoring because we can say what multiplies to give us positive 4 and adds to give us negative 4. When you do that, it would be z minus 2 and z minus 2. I prefer to write it like this, but what I have written is correct. But because it's the same factor, I would write it as a square. Okay, now this problem, you notice you can take a 4t squared out. So when you do that, you have t to the 4th, and this is where students get a little confused, minus 5t squared plus 6. This is actually simple AC factoring. We're still going to say what multiplies to give us positive 6 and adds to give us negative 5. The difference in this problem is we need to get our terms to multiply to be a t to the 4th and add to be a t squared. So what does that is t squared. T squared times t squared is t to the 4th, and when you add it, it's still t squared. So it's really not any different than what we've been doing. It's just that you're doubling the exponent. So what multiplies to give us positive 6 and adds to give us negative 5 will be negative 2 and negative 3. We want to make sure these cannot be factored further, and they are not perfect squares, so we're done. Okay? You can go ahead and pause the video and try the you try on your own. Okay, now this is probably most difficult for students is factoring the sum and difference of two cubes. I would highly recommend knowing the pattern, okay? And we're going to talk about it as I do the problem. So for sum of two cubes, I'm going to go ahead and look at this one. I need to know what my a and b are. My a and b are what happened when you cube root each of these terms. So this problem, my a is 2x and my b is 3. I'm going to go ahead and plug that into here. So our first parenthesis is always going to be just a and just b and whatever sign we already have. So it's going to be 2x plus 3. The next parenthesis is going to be a squared. Make sure you square the entire thing. That would be 4x squared. And then you're going to square b squared and put it at the end. Okay, and then for the middle term, it's just a times b, so it's just 6x. Now what usually happens is students get a little confused on what to do with signs. So there's a way to remember it, and we call it SOAP. The first one is we keep the same as the original. Then the O stands for opposite. And the last, the AP, stands for always positive. That's it. Okay, let's look at this one. Now before I do sum of cubes here, these are not perfect cubes. I have to factor something out. So I factor out a 2z squared. When I do that, I get 8z cubed minus 125. Now I have perfect cubes. I have perfect cubes where my a is 2z and my b is 5. Now this time it's difference. So we're going to go ahead and put our a and b in the first parenthesis. Then we're going to square a, square b, and just multiply the two together. Now plug in your signs. Same as the original, opposite of the original, always positive. Now don't forget, you factored this out, so you do have to rewrite it to be correct. Not so bad, right? Okay, go ahead, pause the video, and try the next difference of cubes on your own. Okay, factoring by grouping. Now everybody's good with factoring by grouping because we do this when we do the long AC method. We have 4 terms and we're just going to say, what can I factor out of the first 2 terms? That would be an n squared. What am I left with? An n plus 5. What can I factor out of these 2 terms? A negative 9. Now if you only factored out a positive 9, you would get stuck right away because these parentheses would not be the same, and they need to be. Then we factor out the common parenthesis, and we write our leftovers in the next parenthesis. Now, I'm not done because this is difference of squares. So go ahead and factor further. This is n plus 5, and then n minus 3, n plus 3. If you have a different order of the parentheses, that's okay. It doesn't matter because multiplication is commutative. So if you have it written as n plus 3 times n minus 3 times n plus 5, fine. Okay, let's go ahead and do this one. I'm going to factor out an x squared. So I'm left with x minus 3. Now I'm going to factor out a negative 16. So I'm left with x minus 3. Then I'm going to take the parenthesis out, that's common, and write my leftovers in the other parenthesis. And again, I have a perfect square again, so this one could go further. We have x minus 3 times x plus 4 times x minus 4. Okay, go ahead and pause the video and try factor grouping on your own. Okay? In summary, you should be able to do double factoring like we did up here. You should be able to do special patterns, which would be the sum and difference of perfect cubes. And then you should also be able to factor by grouping. All right, see you tomorrow in class.